students, today we're going to talk about how categorical sentences work. By categorical sentences, these are sentences which say something about groups of individuals. They relate to classes. The subject class, what the sentence is about, with the predicate class, what is being claimed about the subject. So here we've got people. Some people are anarchists linked with the predicate class anarchists. And we have the subject class vertebrates, and all vertebrates are animals linked with the predicate class animals. So what is the subject class for no used books or cups? And which is the predicate class? What is the subject class for some desserts are not bitter? And which is the predicate class? Hint for you guys, not does not function separately. So we give it its own place. So that does not count as part of the predicate class. So categorical reasoning is based on categorical claims which talk about full or partial inclusion or exclusion from classes or groups or categories. So, for example, all tigers are mammals, or all mammals are vertebrates. These are full inclusion. And here's an example of a categorical reasoning. All tigers are mammals, all mammals are vertebrates, thus all tigers are vertebrates. The quantifiers are the words. Quantifiers come from the concept of quantity or of how many the proposition is true. So all of how many, well, every single one of them. Some at least one. Some are not is partial exclusion, and no is total or full exclusion. Okay, so there are four basic quantifiers, sentence types, all SRP, so all subject or predicate, no subject or predicate, some subject or predicate, and some subject are not predicate. So those are the four types of sentences. We're going to be calling them by their letters, and their letters are A, E, I, and O in that order. So a universal sentence we'll discuss first. These represent that each of the individuals in a category have or do not have a particular quality. Universals distribute the term to each and every member. So indicators of universal reasoning include all, every, each and every, everything, anything, and no. So for example, no carnivals are enjoyable and all cats are mammals. Those are both universal sentences. The two main types of universal sentences are universal affirmatives, which we call A sentences, from the word affirmo with the A. We'll also use the I for I sentences, which are partial particular affirmatives. So universal affirmative claims inclusion universally in a category. So bagels are delicious. When we standardize it into standard categorical form, we standardize that into all bagels are delicious. Now, this may seem weird because when somebody says bagels are delicious, they don't really mean all normally, but that's the way we interpret it in order to do our categorical reasoning. And there are times in life where all means all, like each and every single time. And that is how we're interpreting this. We're interpreting it as distributing individually to members of the set or the class. For universal negations, also called E sentences, these claim exclusion universally from a category. So for example, no unicorns have wings. Or another version would be all fjords are not tropical, which when we standardize that becomes no fjords are tropicals. So our standardized universal affirmative is an all sentence. Our standardized universal negative is a no sentence. And we use the letter E for the term nego, which is both the affirmative and nego are both from medieval terms that we still use today. So I want you to identify as A or E the following sentences. All puppies smell good. No puppies are old. People are strange. Dogs don't gallop. No fighters are comedians. Each phone has a case. And finally, broccoli isn't tasty. Now, the other two main types are the particular affirmative and a particular negative. A particular affirmative is called an I sentence for, again, the affirmo for the second part of that. And this claims that there's at least one thing included in a particular category. So even in colloquial English, if I say some people are coming to a party, I am sort of indicating more than one. Technically, logically, if at least one person comes to the party, then some people are coming to the party has been satisfied. So some men have beards means logically there is at least one man who has a beard. Here are two other examples of affirmatives, particular affirmatives. Someone is married to Beyonce, and hotels that serve consomme exist, which means some hotels are places that serve consomme. Again, I'm going to, whenever I do which means this, or we will say it in standard form, I'll teach you how to do standard form as well. I just want to introduce you to it early. A particular negative, again, this one comes from Niga, so it's the O sentence. A particular negative is an O sentence. These claim partial exclusion between categories. So I can say some men do not have beards, which means there is at least one man who does not have a beard. I want to stop for a second and just say, if I say some man has a beard, that does not logically imply that there is somebody who does not have a beard, just as if I say something has mass, does not logically imply that something does not have mass, okay? So here are particular negatives. Some asparagus are not green. Some pigs aren't airplanes. There exists a human who doesn't have a moral compass. So for these, we're going to use I for particular affirmatives and O for particular negatives. So tell me if this is an I or an O sentence. Some houses are made of wood. Some yellow fruits are not bananas. Vain cats exist. Some people are not fond of boats, and some cats are orange. So here's how we standard form our sentences for our categoricals. And this is what we do before we analyze them. We take, if we have a sentence, for example, that says cats aren't playful, we convert that into our E sentence. No cats are playful. So when we have a sentence like persons think, it gets a little awkward when we standard form it, but we put it into all persons are thinkers. What we're doing here is we're putting a copula, which is the word for the connecting word are, between the subject and the predicate to make it clear what the relation between the classes are. So we'd put all subject or predicate for an A sentence. For an I sentence, some subject or predicate. For an E sentence, we standard form that as no subject or predicate. And for an O sentence, we standard form that as some subject or not predicate. So if we have there exists a cat that isn't playful, we transform that into our O version, and we get some cat is not playful. So stop this if you don't, or open the PDF and look this up. Convert these into standard form. Every cat has a face. Oh my God, why did I say that? Sorry, I misread that. Every smile has a face. Orange cats exist. Art exists that is not sculpture. All reptiles are not mammals. Sled dogs run. And any event is a happening. Okay. So I'm just going to introduce you to Venn diagrams. You have the choice to learn how to use these independently, but they sometimes help us clarify the relations between the different classes. So this is a logical system that's used to express categorical propositions and also to test inferences. The area in the denoted circle, so here we have dogs, represents where members of the class would be. So everything inside this circle would count as dogs, and everything outside the circle would count as non-dogs. When we use the word non and we attach it to a class, then that's what we call the complementary class. The area outside the circle represents all the other individuals. That is the complementary class. So non-dogs include things like pens and paper and cats, et cetera, et cetera. Empty space represents no information, okay? So I want you to think about this yourself. I want you to name 3 things that are non-dogs. For categorical statements, the left circle represents the subject class and the right circle represents the predicate class. Shading represents the information that nothing can exist in that area, and an X represents there is at least one or something that is in that class exists. So here are our 4 main types of categorical propositions. For our A, what we would do is we would shade in. So if we look at these circles and we look at the overlaps, we've got 3 main areas. 1, where you have the subject without the overlap. 2, the middle area, which is the overlap of both subject and predicate class. And then 3, which is the predicate class, but not the subject class. So in this case, we would shade in all of area 1, so that if anything exists, it would have to exist both in the subject class and the predicate class, or just the predicate class. For E here, we would shade in the overlap area 2. Okay, so areas 1 and 3 would be empty. This is saying nothing can exist in that overlap between the subject and the predicate. Next, we have I, we put an X to indicate there is something that exists in the subject and the predicate class at the same time for some subject or predicate. And for O, we would put the X in the subject, but outside of the predicate class. And this would say some S are not P. Okay, so look at this, get a good idea of it, and take out a pen and paper and recreate those diagrams for each of the main types of categorical propositions. Now I want you to match the statement to the Venn diagram. So number 1, no animals are umbrellas. Number 2, some animal is not an elephant. Number 3, some animal is an elephant. And number 4, all elephants are animals. So when we use this word are or is, this is called a copula, and this can work to connect the subject and the predicate phrase in different ways. The first way it can connect them is it can connect an individual to a category or class. So I can say something like Hipparchia is wise. Hipparchia is a named philosopher from the ancient world, and I'm saying she belongs to the predicate class wise. That's called the is of predication. Next, we're going to do the categorical is. This is the is we'll be working on with categorical statements. This connects a category with another category. Okay, for example, philosophers are stubborn. The next meaning of is the is of existence. So if I say, I think, therefore I am, for example, the I am part connects me as an individual to reality or to the actual world. Finally, the last one is the is of identity. This connects an individual to an individual. For example, Lewis Carroll is Charles Dodson. So those are the ises of predication. Categorical is, existential is, and the is of identity. So match the type of is of predication, categorical, existential, or identity to the following sentences. Scott Miss Cuddy is Kid Cuddy. Carrots are vegetables. Keanu Reeves is kind. Avocados are green. Lizzo is Melissa Vivian Jefferson. Now we have to get into the way to interpret universal statements. There's two ways to think about them prior to doing our logic on them, and we're going to learn how to do both ways of conceptualizing them. So first, I want to talk about Aristotle's traditional interpretation. Okay, so the first way to interpret is called the traditional interpretation, and this is the way that the original person creating categorical reasoning, who is Aristotle, interprets it. So Aristotle is both a logician, he's also a scientist, and he's going and exploring the natural world, and he's really interested in categorizing the natural world. So for him, logic is not this sort of abstract thing. It's something that is very helpful for science and for inquiry in general. So since logic is talking about things, it should be only talking about things that are intelligible or cognizable to other intelligent beings. So when when somebody is talking about something, you're going to assume that what they are saying implicitly is that thing exists. Okay, I want you to, if this is hard for you to conceptualize, I want you to think about vampires. Okay, imagine getting into a conversation with somebody wherein they're treating vampires as an actual ontological category, meaning a being that exists. Okay. And they're trying to get into an argument about, no, vampires are sparkly or vampires aren't sparkly. Okay. You might get frustrated like Aristotle would, because the fact of the matter is there is no thing that is a vampire for us to be comparing to, no intelligible object for us to be looking at in the world to say, no, actually, yeah, you're right. Vampires are sparkly. Okay. So now that we sort of see this naturalistic bent of Aristotle's, we can understand that when you are talking about things, particularly categorizing them, he assumes that you're talking about something that exists. Whereas Boole, who we've talked about already, Boole gives a modern interpretation. So for him, there are things that are understandable to, cognizable to the human mind, that are intelligible, yet they don't exist in reality. So they're not something that we can all observe and look at and say, yeah, you're right. Okay. So intelligible means here to be comprehensible, but not necessarily observable. And that's where Boole and Aristotle disagree. So, if Aristotle says all bears are animals, this implies that some bear that is an animal exists. And if Boole says all bears are animals, this simply does not imply some bear that is an animal exists. Okay, so active reflection here. This is for you to just do a thought experiment. So like a scientific experiment, you have certain parameters, and then you imagine within those parameters. So mythological creatures often rely on known parts of various entities. For example, a griffin is an eagle plus a lion. So I want you to build your own monster or mythological creature out of parts of various entities. Describe, I don't know how to say, in discussion for the people in our in-person class, for you guys at home, maybe you can talk to your friends about building a monster. Is your non-existent entity intelligible or not? Are you more Boole or more Aristotle. So here is what we call the modern square of opposition. What this is this is just a diagram that is supposed to help you understand the basic rules of categorical reasoning for the way Boole conceptualizes universals. So in this case, A and O are opposite, and I and E are opposite, which means they contradict each other. So if E is true, then I is false. And if I is true, then E is false. Okay? And if A is false, then O is true. And if O is false, then A is true. Okay? So I want you to apply the modern square of opposition. Suppose no Vikings are finished. The way I do this is I'll take my annotation out, I'll have my square of opposition. And for this one, no Vikings is up here for me. So no Vikings, no V are finished. Are finished is the way that we do this. So I put it in that corner. Okay. So if that is true, or did I say true or false? Let me look back. Sorry, if that is false, okay, then we don't have any info because we have no relation between A and E, and we don't have any info for E and O. But if we know that E is false, what do we know about I? If E is false, I must be true. So here you're going to go through all of the possible values. And for the modern square, you're only ever going to be able to determine the one that contradicts it. Okay? So apply the modern square of opposition yourself. Supposing no Vikings are finished is false. Is the sentence some Viking is finished true, false, or undetermined? Is the sentence some Viking is not finished true, false, or undetermined? And is the sentence all Vikings are finished true, false, or undetermined? Again, I want you to apply the modern square of opposition. If some Vikings are not finished is true, what is the value of no Viking is finished? What is the value of some Viking is finished? And what is the value of all Vikings are finished? Finally, apply the modern square of opposition. If some artists are not panthers is true, then what is the value of all artists are panthers? If no beavers make vanilla ice cream is true, then what is the value of there exists a beaver who is a vanilla ice cream maker? Sorry, I clicked on that too quickly, but here is my diagram for the traditional square of opposition. You're going to notice that it still contains the contradictions between A and O and E and I. So it contains the basic inferences that are allowed in the modern square of opposition. But the traditional square, because of the assumption that existence is real, the traditional square includes existence as an assumption via Aristotle. Okay? So that gives us more inferences to work with and to be able to ascertain. So I'm going to very briefly go over this, and then we're going to go over each and every individual part. So at the top, I have our contraries, A and E, and I'll explain their relation to each other. At the bottom, we have our subcontraries, I and O. On the sides, we have what we call our subalternates. Okay, so the side indicates what we call subalternation. So we have two arrows because they alternate, one going down and one going up. Okay, so that's the setup here. Now you'll also notice that I have a thumbs up on the bottom, this emoji, and a poop emoji at the top. The reason I have this is because I want you to remember a basic idea of this diagram that truth falls down and poop floats. Okay, so what is false goes up in this diagram, and what is true comes down in our subalteration. So here I have set it up so you can look at it with a little more, little more specificity, wherein I have true going down for the blue arrows and false going up. That's the relation between A and I and E and O. Then I have this set up where it says true, false, false, true. This gives all the possible accommodations of our contraries, A and E. Either one is true while the other is false, they're both false, or one is false while the other is true. For our subcontraries down here at the bottom are I and our O. These are the possible combinations. Again, true. Again, true goes down, so they could both be true. One could be true while the other's false, or one could be false while the other's true. Those are all our possible combinations. And again, we have our contradictoriness retained in our traditional square of opposition. You may also conceptualize this space as a cube with negated versions of the categorical statements represented on the back, or as a syllogism. Here is what I mean by we can imagine this as going into a cube, and with the back, the negated versions of the front. And here, when it stops, I'll show you the. So here we have our contraries, A and E, and I and O here, and we can imagine it that way as well. Further on, when you are using this later on to check to see if arguments are valid or invalid, you can look at this cube to indicate which premises are which and what the conclusion is. Okay, so let's start with our subalternates. We can think of this as alternating, okay? One goes one way, one goes the other way, okay? So A and I and E and O are subalternates, meaning if we take existential import, right, we do the assumption that Aristotle does that A and E require that whatever they're talking about exists, okay? Then I and O have a particular relation. If A is true, I must be true as well. If E is true, O must be true as well. Now, on the other hand, if I is false, A must be false. So let me give you an example. If all pencils are writing instruments, then some pencil is a writing instrument is true. Okay. If some reptile is a mammal is false, then all reptiles are mammals would be false as well. Okay, let's do it with the E, okay? So if I say no pencils are reptiles, which is true, then it's true that some pencil is not a reptile. Now, if I say false, some are not, like some mammals are not vertebrates, which is false, then no mammals are vertebrates would necessarily be false as well. So that is subalternation. So first assume the traditional square of opposition. If some artist is a painter is true, what is the value of all artists or painters? If some barrel is not a mammal is false, then what is the value of no barrel is a mammal? If no opossums or rabbits is true, what is the value of some opossum is not a rabbit? So this, we are using our traditional square, so we're checking for subalternation. Next, we have contraries. Okay, so this exists on the top row. It's a relation between universals. Now, I'm going to say a universal sentence is true, okay? And I want you to notice how that'll make the other one false. So if I say all mammals are vertebrates, that's true. No mammals or vertebrates would have to be false then. They both can't be true at the same time, or as I say, false floats, okay? They can both be false at the same time. I could say all mammals are dogs, and no mammals are dogs. Okay, both of those are false. So that's contrariness. So you can have this possible combination, true and false, or false and true only. So I want you to practice your inferences this way, using the traditional square of opposition. If no artist is a painter is false, what is the value of all artists are painters? If all horses are markets is true, then what is the value of no horses are markets? And finally, if all horses are markets is false, then what is the value of no horses are markets? So those are testing the contrary relation. Now we have subcontraries. This is our last in our traditional square. These are the relation between our I and our O sentences. This is truth, right? Truth sinks. These can both be true. Some men are not bearded, and some men are bearded can both be true at the same time. One could be true while the other is false, or one could be false while the other is true. Okay, and those are the possible combinations of our subcontraries. So now, assuming the traditional square of opposition, if some artist is a painter is true, what is the value of some artist is not a painter? True, false, or undetermined? If some artist is not a sculptor is false, then what is the value of some artist is a sculptor? If some artist is a pinky is false, then what is the value of some artist is not a pinky? Now that you have all of those, you can use a traditional square and run, knowing the value of one of them, you can run it through all of the possible ones. So you can take it, on this one we have an A sentence, all dogs are marsupials, and we're saying this is false. So an A is false. So then we can run it through and see what the values of our E, our I, and our O are. So what is the value of no dogs are marsupial? Some dog is a marsupial, and some dog is not a marsupial. Again, I'm just making you run these through the traditional square. If we have no man is an island is true, okay, and this is an E sentence, then what is the value of our A sentence? All men are islands. Our O sentence, some man is not an island. And finally, our I sentence, some man is an island. As if you haven't done enough, again, you're just going to want to keep pausing and practicing these exercises so you get good at this. We're going to be doing the O sentence, some witches are not burned at the stake. If this is true, what is the value of all witches are burned at the stake? Some witches are burned at the stake, and no witches are burned at the stake. Last thing I want to talk about are what we call immediate inferences. An immediate inference is simply going from one sentence to another sentence. So you can think of them as one premise arguments or one step arguments. So the first thing that we can do that is an immediate inference is what we call a conversion, to convert a sentence. In this case, we're just going to flip the term. So you want to keep the quality. So if it's negative, you want to keep it negative. If it's affirmative, you keep affirmative. Okay. And you want to keep the quantity. So if it says all, then you keep all. If it says no, you keep no, et cetera, et cetera. And then you're just going to flip the subject and the predicate. Okay. This creates logically equivalent sentences for the E and the I sentences, but it does not work for O and for A sentences, okay? So if we have an E sentence like no living animals are made of concrete, and this is true, then no things made of concrete are living animals would be true as well. If some objects are plastic is true, this does not entail that some plastic things are objects. Oh, sorry, does entail. It does not. So this works for our E and for our I. If you remember from earlier on, and I'm just going to draw these up, one of the reasons this works is because we can see it more carefully, more easily in our Venn diagram. So here I've got my subject and my predicate classes, S and P. Okay. And for some objects are plastic and some plastic things are objects. What I do is I just for our Venn diagram put an X in between this, and it can be read symmetrically, either backwards or forwards. And we'll notice the same thing can be true for our E sentence, okay? In which we have to, cross out all of the overlapping area. And this is our E sentence. And we can see again that this can be read backwards and forwards because it's symmetrical. I've highlighted the E and I in the word conversion to get you to remember it works for E and I, but it doesn't work for the other ones. So all animals are made of organic matter does not logically imply the converse, that all things made of organic matter are animals. And same with our O, some animals are not mice, does not logically imply that some mice are not animals. If you're unsure about these, you can test them with real sentences, and sometimes the logic comes more clearly through. So convert these two and determine true, false, or undetermined. If no carpets are blue is false, what is the truth value of the converse? No blue things are carpets. If all people or organic things is true, what is the truth value of the converse? All organic things are people. Remember, if it doesn't work, then it remains undetermined. Okay, this is the same for contraposition. Contraposition creates logically equivalent sentences for our A and our O, but not for our E and our I. For this one, what we're going to do is the same sort of thing, but we're going to flip it and reverse it. Okay? So when we contrapose it, we take a sentence and we flip the subject and the predicate, but we add non to the predicate and to the subject if they don't have non. And if they do have non, we take it off. So we unnon the non and we non the unnonned. So all humans are mammals, contraposed becomes all non-mammals are non-human. And because this is an A sentence, it retains the same value. So if this is true, it stays true. Whereas no carrots are fruit becomes no non-fruit are non-carrots, which is not a valid immediate inference. So given this rule for contraposition, flip it and reverse it. Remember, the term complement is the non-ed or the unnonned version of the class term. So true or false, the term complement of the term complement of artichokes is non-artichokes. The term complement of non-poisonous is not poisonous. Finally, contrapose this sentence, all non-flammable blankets are non-cotton. If it is true, what is the value of the contraposed sentence? Next, I'm going to teach you, or last, I'm going to teach you how to obvert. To obvert a sentence, one switches the quality from negative to affirmative or affirmative to negative. So go from all to no, or say some to some or not, or vice versa. And then you're going to just replace the predicate with its term complement. Obversion creates logically equivalent sentences for all types of categorical claims. Okay? So some animals are not mice becomes some animals are non-mice. So you get rid of the not and you replace it with a non. All cops eat donuts becomes no cops are non-donut eaters. And finally, no islands are home to dolphins becomes all islands are non-dolphin homes. You can see sort of intuitively that they're logically equivalent. So your last active learning exercise, assume no animals were hurt in this film is true. Match the immediate inference to the correct value, true, false, or undetermined. For obversion, contraposition, and conversion. Again, on the sentence, no animals were hurt in this film. Next, assume some dessert is chainmail, is false. Match the immediate inference to the correct value, true, false, or undetermined. So first you want to obvert some dessert is chainmail, then contrapose it, then convert it and see what the values are. So here, this is what you learned how to do. Define, identify, and construct universal sentences and particular sentences, identify types of copulas, put categorical propositions in a standard form, identify and construct Venn diagrams for categorical propositions, and use the traditional and modern square of opposition, as well as learn how to identify, define, and find immediate inferences.